Now we will look at some basic properties of addition. And the first property we talk about is called the commutative property. If you think about the basic addition facts, you should know that 3 plus 4 equals 7. And you should also know that 4 plus 3 equals 7. It doesn't matter if I have the 3 first and then the 4, or if I have the 4 first and then the 3. And that pattern holds true for any numbers that we want to add together. If we're adding two numbers, it doesn't matter which one comes first. The order doesn't affect the answer. We say that addition is commutative. That's what that means. It means that the order of the numbers does not affect the result, or the sum. This fact is referred to as the commutative property of addition. Okay, a couple of examples. 8 plus 2 would be the same as 2 plus 8. I know that 8 plus 2 is 10, and I know that 2 plus 8 is 10. Now the second example, 3,479 plus 12,892, I don't know what those numbers add up to. I didn't memorize my addition table out to the 12,000s. But I do know that 3,479 plus 12,892 will be the same thing as 12,892 plus 3,479. The point is that I can reverse the order and they will still be the same. They'll still be equal to each other. Those two numbers added that way is equal to the same two numbers added the other way. Next, we will talk about the associative property of addition. Sometimes it's useful to group numbers together. That's especially true when we're adding more than two numbers. Think about this. 8 plus 4 plus 3. I want to add three numbers together this time. I could do this. I could add the 8 and the 4 first. I could say 8 plus 4 plus 3. And these parentheses indicate that I do that first, the 8 plus 4, before I add the 3. So 8 plus 4 is 12. So 8 plus 4 plus 3 is equal to 12 plus 3. And you can probably see that that's 15. So I grouped the 8 and the 4 together. But if I wanted to, instead of associating the 4 with the 8, I could associate the 4 with the 3. And I could write it like this. 8 plus 4 plus 3. What does that equal? Well, now we do the 4 plus 3 first because it's in parentheses. So 4 plus 3 is 7. So this is just like saying 8 plus 7. So I'll write that. 8 plus 7. And 8 plus 7 is also 15. We had different steps along the way, but we have the same number. It doesn't matter whether the 4 is associated with the 8 or whether it's associated with the 3. It doesn't affect the outcome. Now, most math books go over those concepts, the commutative property and the associative property, but they don't often show how useful they can be. And I'm going to show you some examples here that show you that these ideas, the associative property and the commutative property, can come in really handy when we're adding long lists of numbers. If you're adding a bunch of numbers together, it's often, not every time, but often possible to find groups of numbers or pairs of numbers that add up to 10 or multiples of 10, and then the sum can be computed quickly and easily. Not necessarily in your head, but with minimal amount of effort, you can find an answer. Like right here, 7 plus 12 plus 3 plus 8. Instead of just adding 7 and 12, and then adding 3, and then adding 8, I look at the numbers for a second, and I notice, hey, the 7 and the 3 add up to 10. So I'm going to underline those to keep track of things, and just write the 10. I've got 10 so far, underlined. And then I have 12 and 8, and I can see that those add up to 20. So I have another 20. And then 10 plus 20, that's pretty easy to do in your head. 10 plus 20 is 30. Look at this list here in this second example. Let's look at the list and see if we can find some things that add up easily. And we'll mark them as we go to keep track. 15 and 5, that adds up to 20. So I'll write down 20, and I'll leave those underlined. And then let's look at the 3. Well, the 3 and the 1 add up to 4, and then with that 6 also, that gives me 10. So I mark those differently just to keep track of them, to 3 and 1 and 6 adds up to 10, so I'll write down the 10. And then I have 11 and 3 left over there. The 11 and 3, they don't combine to anything nice and neat, but they are 14, and I can write that down. And this, once again, is something you can probably do in your head. 20 plus 10 is 30, and then add 14 to that. And if you want to, you can write down that step, 30 plus 14, and that equals 44. If you can go from here to there in your head, that's fine too. But if you want to write down that step, just to be careful, showing your work and being careful along the way is also a good idea. Okay, this example. Does anything stand out here? Well, the 38 and the 2 together give me a 40. And then I see this 1 and 4, that's 5, and this 5 here, that gives me 10. And then look here, there's a 16 and a 4, that gives me 20. And then I have this 7 at the end, or the 7 left. So 40 plus 10 is 50, plus 20 more is 70, and then I have that 7, so I have 77 is my answer. There's one more example here. What can we find here that adds up nicely? There's different places you can start. There's not necessarily one best way to do it, but I notice right here, I notice an 8 and a 22. Those combine to give me 30. So I'll mark those so I don't end up reusing them accidentally. And then I see, let's see, I see the 2 and the 18. That adds up to 20. So I'll mark those. And then I see the 7 and the 3. That gives me a 10. And then a 6 and a 4. Those also give me a 10. And then these don't add up nicely to anything, but I can do that in my head. 5 plus 2 is 7, and then 6 more is 13. So I put the 13 down there. And then hopefully the final answer you can do in your head. 30 and 20 is 50, and then add another 10 is 60, and another 10 is 70, and then 13 more is 83. So the fact that the numbers can be rearranged, that the order doesn't matter, that I can associate any number with any other and add them up, that allows me to do this mathematically. That says that I can rearrange these and mix and match pieces and find pieces that I know, and as long as I keep track of things, I can add them together in any order and any association. And a lot of times that can make your arithmetic easier to do. Now, just to be complete, most textbooks also throw this in. Adding 0 to a number is the same as not adding anything at all. So 5 plus 0 is 5, or 0 plus 213 would be 213. Hopefully you knew that already, and hopefully you see that as so obvious that it's hardly even worth stating. But just to be complete, we show it here, and we point out that the number 0 is called the identity for addition, and that the fact that adding 0 to a number doesn't change anything is called the additive identity property. Again, it's so simple that we won't spend any more time on it, but just to be thorough, that's something that you should have seen.